Earth spinning faster, the urgent leap-second dilemma. Imagine a world where every day is a tiny bit shorter than the one before. It sounds like science fiction, but it's happening right now. Earth is spinning faster, making our days marginally shorter, and causing scientists and timekeepers to sit up and take notice. Just recently, July 10th was the shortest day of the year so far, clocking in at 1.36 milliseconds less than 24 hours. And this is the part most people miss. These exceptionally short days are not isolated incidents. They're part of a growing trend. According to data from the International Earth Rotation and Reference System Service and the US Naval Observatory, July 22nd and August 5th are expected to be even shorter, with predictions of 1.34 and 1.25 milliseconds shaved off the day respectively. But here's where it gets controversial. These seemingly small discrepancies can have far-reaching consequences for our modern world. Computers, satellites, and telecommunication systems all rely on precise timekeeping, and even smallest deviations can cause significant problems. In fact, some experts believe we could be facing a scenario similar to the Y2K problem, where modern civilization teeters on the brink of chaos due to a glitch in timekeeping. To understand why this is happening, we need to delve into the science of atomic clocks. These precision instruments count the oscillations of atoms held in a vacuum chamber to calculate 24 hours with the utmost degree of accuracy. This time is called UTC, or Coordinated Universal Time, and it's the global standard for timekeeping. But even with atomic clocks, we still need to account for the slight irregularities in Earth's rotation caused by factors like the gravitational pull of the moon, seasonal changes in the atmosphere, and the influence of Earth's liquid core. The irony is that while climate change has caused numerous problems, it's actually helping to slow down Earth's rotation, counteracting the forces that are making our days shorter. According to a recent study published in Nature, melting ice sheets in Antarctica and Greenland are spreading over the oceans, much like a skater slowing down when they tuck in their arms. Without global warming, we might already be facing a negative leap second, a concept that was never even considered when the leap second system was introduced in 1972. The prospect of a negative leap second raises significant concerns. After all, positive leap seconds have already caused problems after 50 years of implementation. Can we really trust our systems to handle a negative leap second, which has never been tested or tried? And what about the potential impact on financial transactions, electric grids, and GPS satellites? As we stand on the brink of this unprecedented change, one question lingers in the air. What does this mean for our future? Will Earth continue to spin faster, or will it eventually slow down again? The answer is uncertain, but one thing is clear. We need to be vigilant and prepared for whatever lies ahead. So tell us, what do you think about the idea of a shorter day? Is it a fascinating scientific phenomenon or a potential disaster waiting to happen? Share your thoughts in the comments below. Hurry up! Why scientists predict shorter days on Earth. Today might be shorter than usual. Here's why. Did you know that scientists predict the day could be just a fraction of a second shorter than normal? It sounds minor, but this tiny variation is actually tied to the Earth's spinning motion, which is constantly influenced by forces we might not even notice. Let's break down what's happening beneath the surface. The Earth doesn't spin at a perfectly steady pace. Tiny shifts in weather patterns, ocean tides, and even the liquid core deep inside our planet can tweak the length of a day. NASA has confirmed that on July 22nd, the day will likely be about a millisecond shorter than a standard 24-hour cycle. This isn't a new phenomenon. On July 9, the Earth's spin even shortened the day by nearly 1.4 milliseconds. But why is this getting so much attention? But here's where it gets controversial. Recent headlines have framed these short days as freakishly unusual, even though they're part of a long-standing pattern. Scientists like Dennis McCarthy, who has written extensively on Earth's rotation, say these variations are just one of many natural fluctuations. We've known about Earth's variable rotation for over a century, he explains. This is just another little twist in the story. So what causes these changes? The moon's gravitational pull plays a big role, creating tides that slowly slow the Earth's spin, the process called tidal braking. However, a new angle is emerging: climate change. A study published in Nature found that melting polar ice and shifting water toward the equator could lengthen the day. Meanwhile, another study in PNAS warns that in extreme scenarios, climate-driven water redistribution might even make days longer, putting humans in the spotlight as a key driver of Earth's rotation. And this is the part most people miss. While individual days may seem trivial, understanding the Earth's rotation is critical for everything from satellite navigation to precision agriculture. For instance, at the equator, the Earth spins fast enough that in 1 second, it covers the length of 4 football fields. Even small variations in rotation can add up over time, impacting patterns that rely on exact timing. Here's the catch: predicting Earth's rotation becomes less accurate the further ahead we look. Scientists use data from radio telescopes pointing at distant quasars, fixed points in space, and GPS systems to track these changes. But with climate change accelerating, the role of human activity in shaping the day's length is becoming harder to ignore. As researcher Benedict Soja of ETH Zurich puts it, we could become the dominant drivers of Earth's rotation through our own climate actions. So what does this mean for us? While a shorter day might feel like a fleeting moment, it's a reminder that even the smallest changes in our planet's motion can have far-reaching consequences. What do you think? Should we start tracking Earth's rotation more closely? Or is this just a minor quirk of nature? Share your thoughts in the comments below. Earth's 2-second shortest day ever, on July the 22nd, 2025, explained. Why is Earth spinning faster? Our planet is breaking speed records, and no one fully understands why. Today, July 22nd, Earth will complete its daily spin 1.34 milliseconds faster than the standard 24-hour cycle, marking the second shortest day ever measured. While imperceptible to humans, this tiny time difference signals a larger mystery. Earth's rotation has been mysteriously accelerating since 2020, defying long-term trends and leaving scientists scrambling for answers. But here's where it gets controversial. If this acceleration continues, we might need to subtract a second from global timekeeping systems by 2029, an unprecedented move that could disrupt digital infrastructure worldwide. Are we prepared for humanity's first ever negative leap second? Let's rewind Earth's clock. For billions of years, our planet's rotation has been gradually slowing due to tidal friction from the moon. Imagine the moon as a cosmic brake pedal. As it drifts 1.5 inches farther from Earth each year, it transfers rotational energy away from our planet. This process once gave Earth 19-hour days during its youth and continues to lengthen our days by about 1.8 milliseconds per century. Yet since 2020, Earth has repeatedly broken speed records, with July 5th, 2024 claiming the all-time shortest day at 1.66 milliseconds under 24 hours. The plot thickens with 2025's predictions. While scientists initially flagged July 9th, July 22nd, and August 5th as potential record breakers, new data reveals July 10th already stole the crown at 1.36 milliseconds. Today's 1.34 millisecond shortfall makes July 22nd the current runner-up, with August 5th projected at 1.25 milliseconds. But here's the twist. The acceleration might be losing steam. The rate of change appears to be slowing, yet the root cause remains hotly debated. Could climate change be involved? A 2024 study suggests melting polar ice redistributes the Earth's mass like a figure skater pulling in their arms. But instead of speeding up rotation, this might actually be slowing the acceleration. The real culprit could lie 1,800 miles beneath our feet. Some researchers propose that the Earth's liquid outer core, a seething nickel-iron ocean, might be slowing down, transferring angular momentum to the planet's solid mantle and crust. We're essentially watching a planetary-scale turn of war, explains Leonid Zohov, the leading Earth rotation expert. Current atmospheric and oceanic models can't account for this sudden acceleration. The answer must be buried in Earth's deep interior. Zotov predicts this speed boost might be temporary, with the long-term slowdown eventually resuming. But what if he's wrong? Could we be witnessing a fundamental shift in Earth's rotational behavior? This raises provocative questions. Should we intervene in timekeeping systems for a phenomenon we don't fully understand? How might the negative leap second affect GPS networks, financial markets, and power grids that rely on nanosecond precision. And here's the kicker. Could Earth's core movements create unpredictable speed bumps in our daily timekeeping? As you check your clock today, remember, you're living through a geophysical detective story. The next time someone complains there aren't enough hours in the day, tell them they're literally right, and that scientists are racing to understand why. What's your take? Is this a temporary blip or the start of a new planetary pattern? Share your thoughts below. The answer might reshape how we measure time itself. Stay updated on cosmic mysteries with our space news alert. For deeper dives, join the conversation in our space forums. Jamie Carter brings celestial mechanics down to Earth through his science journalism, translating complex astronomy into engaging stories. As editor of whenisthenexteclipse.com and author of beginner-friendly stargazing guides, he specializes in making cosmic phenomena relatable to everyday runners.